Astronomers just captured the sharpest images ever taken of asteroid 44 Nysa and found it is built from 3 separate lobes fused together, joined by 2 deep valleys that wrap around its 47-mile-wide body, along with a small moon orbiting at a distance of at least 106 miles. That makes Nysa the first confirmed three-lobed object ever found in our solar system. A shape nobody expected from an asteroid that has been known and catalogued since 1857. 2 separate observatories, the Large Binocular Telescope in Arizona and the Very Large Telescope in Chile, independently captured high-contrast images sharp enough to resolve surface detail on an object this small and this far away. This story covers how astronomers confirmed the three-lobed shape, what the newly found moon adds to the picture, and how solid a claim like first known this shape really is. Nysa orbits in the asteroid belt between Mars and Jupiter, hundreds of millions of miles away, which normally makes resolving its actual shape from Earth close to impossible. Asteroids at that distance are usually just points of light even through a large telescope. Researchers got around that limit using 2 specialized high-contrast instruments, SharkWiz on the Large Binocular Telescope and Sphere ZIMPOL on the Very Large Telescope. Both originally built to directly image faint planets next to bright stars by cancelling out glare and atmospheric blur, pointed at Nysa instead during observation windows in February and March of 2026. That same glare-cancelling precision let researchers reconstruct the asteroid's actual, 3-dimensional shape rather than just its brightness or a rough silhouette. What came back was an irregular body roughly 47 miles across at its widest point, with 2 distinct valleys, which researchers interpret as the narrow neck regions connecting 3 separate lobes rather than one continuous, roughly round rock. Buried in the same set of images was something researchers were not specifically looking for. A small moon roughly 0.6 of a mile wide orbiting Nysa at a distance of at least 106 miles. Making this one of a relatively small number of known asteroids in the main belt confirmed to have a moon of their own. Finding a moon around a 3-lobed parent body raises a specific scientific question. Whether the moon formed from debris knocked loose when the 3 lobes originally collided and fused together, or whether it arrived and was captured separately afterward. Right now, researchers have images precise enough to confirm the moon exists and roughly where it orbits, but not yet enough data to determine which formation story actually happened. That requires additional observation over enough time to track the moon's orbit in more detail. Either explanation would place this among the more geologically interesting objects in the asteroid belt, an object that may be recording its own violent formation history in both its shape and its moon. First known 3-lobed asteroid is the headline claim, and it is accurate to what has been directly imaged so far. But a shape reconstruction like this one is a model built from high-contrast imaging data, not a direct close-up photograph the way a spacecraft flyby would produce. The interpretation that the 2 valleys represent necks joining 3 lobes is the research team's best current fit to the image data, and it is the interpretation other astronomers in the field have found credible. But it has not yet been confirmed by an independent imaging campaign or a spacecraft visit. Nysa has been observed and catalogued since 1857, and no one previously identified this 3-lobed structure, which says more about how much detail these 2 new instruments can resolve than it does about a asteroid suddenly changing shape. Treat the 3-lobed classification as a strong, well-supported finding from the best imaging technology available today. Not yet a settled, independently reconfirmed fact. Quick recap. High-contrast imaging from two separate observatories found asteroid 44 Nysa is built from three fused lobes joined by two neck-like valleys across a 47-mile wide body, with a small previously unknown moon orbiting at least 106 miles out. So, signal or noise? Signal. Two independent telescopes captured consistent high-resolution data. The research has been reviewed and presented by working planetary astronomers, and the underlying imaging technology genuinely can resolve detail on objects this small at this distance. The honest limit is that shape reconstruction from imaging is not the same as a spacecraft close-up. So treat the three-lobed structure as the strongest current model rather than a permanently closed case. Either way, an asteroid orbited by humans in our own solar system for over a century just turned out to be stranger than anyone had measured before. Subscribe for the space stories that explain what a new image actually proves. Not just what it looks like. Signal from the noise. Every week.